Hello, everyone, and welcome back to a new session for Computer Science 1. This session is for week 2, and we're going to go over chapter 2, Intro to C++. We're going to also assign a homework and post a new discussion topic. So for chapter 2, we're going to go over Introduction to C++. Basically, we're going to speak, so chapter, let's do this. I want to increase, so chapter, let's increase the zoom. Okay, so this should be much better. Chapter 2. We're gonna go over parts of a basic C++ program. We're gonna also go over the cout object. We're gonna go over the include keyword or directive. We will also go over variables, literals, and assignment operators. We will also go over identifiers. We will also go over data types. So data types, specifically the char data type. Then we're gonna go over C++ string class. We will go over floating point data type. We will also go over the Boolean data type. We will go over scope, variable scopes. We will go over arithmetic operators. We will go over comments, constants, and if we get more time, we will go over programming styles. So with that being said, let's go ahead and build a basic C++ program and go over the parts. So here I have this basic C++ program. I have 14 lines. First line is blank, second line, third line is blank, fourth line, and so on, so forth. So any C++ program has parts and components that serve specific purpose. Each of these lines serves specific purpose. They are not always in the same place. You might see using namespace somewhere else. You might see include somewhere else. Return doesn't have to be at the end of the function, and so on and so forth. So the lines in this fashion, they don't have to be in order as long as the file has them. So this is my file, it's a .cpp file. As long as the file has at this level, this statement, and then this function, and the scope of this function, then it's a basic C++ program. If I'm missing any of these lines, 1, 2, and the function main, then my program might not and will not work. So let's go over them one by one. Let's type also one more line, and then I'm going to call it a simple C++ program. So this is my simple C++ program. Let's look at this line. This line, and specifically this operator or these two forward slashes, these marks are the beginning of a comment, meaning anything after these two characters will be ignored by the program. So this is just a comment. It's not part of my C++ code. I can type as many comments as I want, and I can put them in any place I want. I can put them here, 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 anywhere I need. All these are comments to be ignored by the compiler or program. So this line is a comment to be ignored. This line is a comment to be ignored. All these are comments to be ignored. There are a lot of usages for programs. They can provide a brief, what the program does. They can provide a brief for what this line does. They can provide a brief for what this function does, and so on and so forth. Of course, you don't want to abuse this feature. Like here, I have a lot of duplicate and unneeded comments. So I'm going to go ahead and remove them and build proper commenting. For example, this is proper. It's the title of my program. And every time I explain a line, I'm going to add a brief comment for what this line does. Now, in future, once you have good practice and experience on building C++ program, then you no longer need to comment what each line does, because at that point, you're going to know without adding extra characters, extra information, you will know what this program or what this line does. For now, I'm going to go ahead and comment each of these lines. So let's look at this line, line number 4. Line number 4 starts with the pound key. It's called a preprocessor directive. This line, any line that starts with the pound key or pound character, is called a preprocessor directive. Think of this line or this preprocessor directive as a program or a way that sets up your source code for the compiler. So here, I'm telling the compiler, I need to include into this file, I need to include this library. The library is IOStream, meaning input, output, stream. This library is provided by the C++ language, and it's a library that gives you functionality for reading and writing into the screen. So it's input, output stream from your program to the screen. Input from the screen, output to the screen, and it's a stream of data. So there is a stream of data that's going to go from your program to the screen, or stream of data that will come from the screen into your program. So here, I'm telling my file or also my program that I would like to use this library from the C++ language. So basically, preprocessor directive for input, output functionality. For screen input output functionality. Now for this line, using namespace std. std stands for standard. This is also provided by the language. Here, the idea is programs usually contain several items with unique names. For example, this cout is unique. This end line is unique. This main is unique, and so on, so forth. So In this chapter, you will learn to create variables of your own or use variables or objects per se for this program. And then in chapter 6, you will learn to create functions of your own. In chapter 13, you will learn to create classes and objects of your own. So with that being said, variables, functions, and objects are examples of program entities that must have names. You cannot use a variable without giving it a name. You can't use a function without giving it a name. You can't use objects without giving them names. So C++ uses namespaces to organize those names of your program or your program entities. The statement using namespace std declares or tells that the program will be accessing entities whose names are part of the namespace that is called std. So anything that I use here and anything that I create here, whether variables, functions, or objects, are gonna be under the umbrella std, the namespace std, the umbrella namespace std. So somewhere else, when I create a different file and I say using namespace std, that will allow me to use stuff that I created somewhere else. So if I go ahead and create another function here, public function, and then in a different file, I include this file, console application, into that other file, just like I included iostream, it will allow the program to recognize that function, because that function and this new file will both be under the namespace std. Think of it as a universe, the universe std. All these are under the universe std. std provided by the language has its own stuff as well, created and provided for you. For example, the cout statement. If I take off this line, then it's not going to know what cout is. It's not going to know what endl is. Although these are respective to this library, but they need to be in a universe, in some universe. I can shortcut by saying std : Now, even though I didn't provide that line, the program knows that I'm using, or I would like to use, the cout statement or cout object from the std universe. Same case, std and l. This way of providing which universe I'm working or I would like to work with helps when you are working with multiple universes. Let's say I have a universe called std, and then I created my own universe called my namespace. For whatever reason, I created my own namespace. So this way of typing code will tell or make it clear for my program that I would like the cout from the standard. And let's say my space that I created, I declared, designed, and created a or an endl object. In this namespace, I designed my own endl object. Let's say the endl from the standard is one new line, and the endl that I created is new, 2 lines. So 2 new lines if instead of 1 new line. So I have 2 universes now. I have my namespace that I designed and created an endl object, and I have the std, which has its own endl, which is object, which is 1 new line. So if I have this case, then I'm going to tell my program, hey, I need to use the cout from the standard library or standard namespace, and I would like to use my namespace endl. So I would like the cout from the standard namespace and endl from my namespace. Why I cannot do otherwise? Because if I say using namespace std and I say using namespace my namespace, both have an endl object. So when I type endl without prefixing it, which namespace, it would be confusing for the compiler. The compiler will say, hey, this endl is ambiguous. Both namespaces have an endl object. I don't understand what you're trying to say. So in that case, I remove these two, and then I specify explicitly the cout from the standard, the endl from my namespace, and so on, so forth. With that being said, I'm going to undo what I typed, and then I'm going to say this allows my program to be declared under the universe std. Now I don't need to specify which namespace I'm working with. Next, we go to line number 9. Line number 9 is int main and open parentheses. This marks the beginning of a function. This way, or this code, having an int main parentheses is the beginning of function called main. A function in general can be thought of as a group of one or more statements. So a function can have only one line or group of lines, group of statements. These lines collectively has a name and is called main. The name of this function in this case is main, M-A-I-N. So anywhere in my program or different files, I can call this function. I can use the function name to basically execute a group of statements. Let's say I need these 3 lines to be used several times in multiple places. Instead of rewriting these 3 lines, and this is a basic C++ program, but imagine a function that has 1,000 lines. If I need to execute that task again, instead of rewriting those X number of lines, I can just call the function by the function name, and this will reference all those lines. So the name is main, and the set of parentheses that follow the name indicate that it's a function. The fact that I have this format, int, some name, parentheses, indicate that this is a function. The word int, in this case, stands for integer. It indicates that the function sends back an integer value to the operating system when it's done executing. So in this simple C++ program, main is the entry point of this program. When I run this program, the first thing that will get executed is the main function. It will start executing these statements, and once it's done, it will return something back. So the operating system will start this program. It will call the function main, tell it, hey, start or execute. Main will start, and once it's done, it will return something back to the operating system. In this case, it's specifying that it will return an integer value back to the operating system once it's done executing. Then we go to line 10. Line 10 in this case contains a single character. That's a single character. This is called the left brace or an opening brace. So these are braces, and this is a left brace or an opening brace, and this is associated with the function. So these two are associated with the function. These two, you can see them here too. These two characters are the body of the function or any function. Then we go to the cout statement. Let's type some comments just so you know. This indicates the function name and return type. This indicates the beginning of the function body. This here is also called function header. This is called the function header. This is called the function body or definition. So this is the function definition, and this is the function header. Then we have a blank line, and then we go to the cout statement. This cout statement, after the opening parentheses, this is, in simple words, and not to overcomplicate things, in simple words, this line displays hello world on the screen. And you will read more about this cout object and this operator later in this chapter. For now, this displays hello world and then new line on the screen. Displays a message hello world on the screen. Then I'm gonna go to this statement. This statement here basically telling the program to pause, to stop. So once I display hello world, I don't want the program to close, because once it returns something to the operating system, it will just shut down. Operating system will say, oh, okay, you're done executing, okay, terminate. So here I'm telling the operating system or my program to stop, hold, and this command will wait for any input on the screen. The screen will say, press any key to continue. Then we're gonna go to this statement, return 0. This return 0 is returning the literal value. This is a 0, just like 12, just like 10, just like 1. I'm returning 0. So this will send the integer value 0 back to the operating system once the program is done. How do I know that? How do I know that the program is done? Because it's the last statement, meaning all the statements in the body has been executed. So the last thing is to return 0 back to the operating system once the program completes or finishes. Now, the value 0 in this case usually indicates that the program finished successfully. But it's not guaranteed, because different computers, different systems, different platforms are different. In this case, on Windows 10 x64-bit in C++, 0 indicates that everything is okay. With that being said, let's comment out what this does. So this tells the program to hold or halt, pause, wait. This tells this sends back the value 0, okay, back to the operating system. Finally, you have this line on 21, which indicates just like above, this indicates the end of the function body or definition. So the opening brace indicates the beginning and the closing brace indicates the end. So from going over this basic C++ program, we learned so far some special characters. The special characters are the special characters that we saw so far, special characters we saw the comment operator, we saw the pound key, we saw the opening and closed brackets, or sometimes called angle brackets. We saw parentheses, we saw braces or curly braces. We also saw double quotations, set of double quotations, opening and closing. This is inside the hello world. And we also saw semicolon. So far, you know what this does. Comment. You know what this does, which is a pound sign for preprocessor directive. Preprocessor directive. This indicates the enclosed file name, or library. So if I go back to my code, here I'm including whatever between these two brackets. This indicates the naming in the header file. So the header function header. So function header. This is indicating the beginning, end of a function, basically function body or definition. This indicates, this is called opening and closing double quotation marks. This specifies literal values. Usually it's a string of characters, such as a message, to be printed on the screen. So if I go back to my program, why it's called literal? Because I'm telling it, I need to see out, and we're going to go over this later. I'm telling it literally what's between these two double quotations marks. So this hello world will be displayed as is on the screen. So if I run, you're going to see that it will display literally what's between these two double quotations. So hello as capital letter, ELLO space world, WORLD, and exclamation mark. So literally as is. Press any key to continue. This is because of the system pause. I press anything to continue and it's done. If I remove this line, for example, comment it out, then it will just terminate. So see, this process, this executable file process, this exited with code 0. So 0 indicates everything is okay. I'm gonna put it back. Now I wanna speak a little bit about this space. Just as how I said, this is literal, because I can add as many spaces as I want, and all those spaces in the code will be ignored. So this statement is exactly the same as the previous statement, because these spaces are not literal. Whatever between the double quotation marks are basically literals. So notice, if I execute this, it's the same behavior, no different, because those spaces are not literal. With that being said, I want to go over this character. This is called semicolon. Colon or column? Semicolon. Colon in O, I think. Colon, yes, semicolon. And it's one word. So let's go ahead and say semicolon. So semicolons indicate the end of a statement. Notice I have 3 statements in this code, and every statement ends with a semicolon. If I do not provide one of them, the program will not start. It's going to say, hey, something is wrong with this code, and I can't build, I can't work. There were build errors. Would you like to continue and run the last successful build? No, you will never want to run the last successful uh, build, because I want to build this, what's in front of me. So I'm going to add the semicolon, and then notice lines are different than statements. So this statement can be on multiple lines. I can say C out, and then new line, this operator, then a new line, then new line. This is no different. The fact that this doesn't end in semicolon doesn't make it its own statement. Once the compiler sees a statement, then it's a semicolon, then it's a statement. So notice with these new lines, it's the same behavior. So semicolons indicate the end of a statement. The statement starts from the previous semicolon or opening bracket to the semicolon. And then notice this statement starts from the previous semicolon to the semicolon. So semicolons indicate the instructions or commands you're trying to execute. With that being said, these are the special characters that we saw so far. So next thing we need to go over is, oops. So we went over parts of the C. So now the C++ object in details. So the C++ object, the concept for C out object, the concept is to display information on the computer screen, simply. So in this section of the book, I have the book in front of me, by the way, and you should. I am on page 31, topic 2.2, the C out object. So the book is telling you that in this section, you will learn to write programs that produce output on the screen. Something literal, some stuff are computational. So I can change it now, for example, and I can say, I'm going to remove those comments because now it's an overwhelming comment. I'm going to just make it back to be simple without a lot of noise. Here we go. So now I have this program that displays hello world. I can change this. I can say programming is great fun. And this will display programming is great fun, literally. And notice it displays a hidden new line, and then the next statement will go on the new line. For example, if I add a new statement, and then I type this professor is the greatest, notice the statement or the sentence will be displayed on a new line, because here I displayed this literal followed by an end line. If I remove this end L, then notice it's all on same line. And if I remove this end L, notice that all are gonna be on the same line. Programming great fun, this professor greatest, press any key, so there is no new line. So the idea in this topic is that cout objects allow you to display stuff or information on the computer screen. In order to remember these operators, as a student, what I remember, or the way I remembered it is, I am think of it as an arrow. I am sending this message to the cout object. So there is like a new, not a new, there is an arrow. Let me get my where is it? Annotate and then spotlight. So notice here I have an arrow from here, an arrow to the cout object. I wonder if I can change the size. Let's see, text. No, it doesn't allow me. Draw this, and let's try now. Is it smaller? No, it's not smaller. Anyway, so this is the cout object. You can have as many cout objects as you want in your program. There is no like limit for it. Then the next thing that the book needs you to know is called escape sequences. So notice in this case, I'm writing characters on the screen, and those characters are surrounded by double quotations. So what if I actually need to display a double quotation? Let's say, I'm gonna say, I would like on the screen, double quotation, C++, double quotation. So I would like literal these characters and this function or this literal sentence. It's gonna confuse the compiler because for the compiler, double quotation indicates the beginning of a literal and the end of the literal. So here it's confusing the compiler. Okay, this is the beginning. Let's zoom in. Okay, this is the beginning of the literal and then this is the end of the literal. And then you have some characters for programming and then open double quotations, close double quotations. So it's confusing the compiler, especially that C++ is not a known keyword. So in order to have that rule broken, I can escape that rule using escape sequences. And that those escape sequences, one of them is backslash. So backslash double quotation, backslash double quotation. This will allow me to actually display a double quotation. So when I tell my literal backslash double quotation, that means use the following character as a literal. It's not for the language, it's not for the C++ programming language, it's part of my literal. Similar case, I'm telling my literal, hey, you see the following character, only one character. The following one character, I would like it to be used as part of the literal. So let's go back. Notice now it's displaying, let's edit properties font. I'm gonna say, yep. I wonder if we can as well put the size layout, width, height. So let's go by window size. So I would like 50 maybe. And the height, let's go by 15. And window position is fine. Let's system position. So now what is the size? Let's go for this position. That would make it properties left, more to the left. No, I would like maybe 115 and top maybe a little down. So let's say, see, no, this is too much. Let's go with a little to the left and a little up, and then let's reduce the size and reduce the width. Okay, so this is much better. Let's keep it here, so this way we see the code and the statement. So I'm gonna close it, I'm gonna run it again, and here it is. So notice double quotations were displayed as is. Another cool thing is I can, within this line, display a new line. So there's a character for a new line, and it is the N character. But how can I tell my compiler or program that this N is not the letter N, it's the indication of a new line. So if I go ahead and run my program, it will display the N letter. However, I meant to display the new line character, so I escape that rule. Now, this character combined is an indication of a new line. So notice now C++ is space hidden character for a new line, then space, like just like we see here, space hidden a new line, space, and then great fun. So this is another escape sequence character. So one escape sequence character, another escape sequence character. Another one is tab, for example. So run. Notice C++ is space tab space great fun. Also, it needs to be escaped because T would be recognized as the letter T. So I'm going to tell my compiler, hey, I meant tab, not the letter T. You also have A for alert. I don't know if you're going to hear it, but this will sound the alert. I wonder if you heard it. Let's increase the volume again at maximum. So this will display an alert. So notice space, alert, space, just like we see here, space, alert, space. Another one is backslash, for example. So here, if I tell it I need to display a backslash, this will confuse the compiler. This will not display a backslash. Notice it didn't display the backslash. So I want to tell the compiler, hey, I need you to ignore the next rule and use it literal. So now this will be displayed on the screen. Here it is. So there are a group of common escape sequences, and I'm going to list them here. So now you know what cout is, and you need to know the common. You need to know the common escape sequence or sequences. You have what you saw, N, you have T for tab, you have A for alert, you have backslash, you also have double quotation, you also have single quotation, because single quotation are gonna confuse the compiler, so you have to escape it. Other stuff you have R for return cartridge, called return cartridge, means like stop, kinda. You also have backspace, meaning you're gonna be, or the compiler will gonna be displaying in linear, and then when you display backslash, it's gonna go backspace, sorry. So for example, let's say I'm displaying Khalil. So I'm gonna display, for example, cal and then backslash il. What this will display on the screen is actually, it's gonna start, let's start from here. It's gonna display the letter K, A, H, A, L, and then backspace. So now it's ready to display on this character, but because of the escape sequence back, it's gonna go back. So it will replace the L with an I and continue. So this literal here will actually display KHAIL. Here it is. So these are the common escape sequences. Then we're gonna go over next topic, which is variables, literals, and assignments. So when it comes to variables, literals, and assignment statements, variables represent storage locations or units, let's call them at this point, in the computer memory. And then you assign literal values or constant values to those storage units or variables. So let's go to the program and let's declare a variable. I'm gonna go ahead and say I need an integer number semicolon. So here I declared a variable called integer. Sorry, the type is integer, and then I gave it a name, number. I can give it any name. For example, I can give it this name, or this name, or this name, anything. So this is under my control as a programmer. I can give this storage unit or variable any name. In this case, I'm gonna give it the name my number, semicolon. So I declared an integer variable called my number. This will tell the compiler I need storage in the memory of this type. I'm about to store this type in that memory. Semicolon, semicolon, end of statement. So done. Then I can assign literal values using the assignment operator to that storage unit. So now I'm telling my compiler, you see that storage unit I ask for, I need to put the value 5 in it. Then I can say the variable stores operator my number. So now I'm giving the cout object two pieces of data. I'm giving it a literal sentence, and then I'm giving it this storage unit. So anytime I type this name, my number, I am referring to this storage unit or this variable. So at this point, when my compiler reaches this statement, it has 5 in that memory. So when I run my program, it's gonna tell me the variable stores 5 or is storing 5. So with that being said, you need to know that you need to know the difference between variables and literals. So this is a literal and this is variable. Literals are constant, if you want to say constant. This statement here between the double quotations will always mean the same thing. Whatever between the double quotations is always T, H, E, space, variable, space, etc. However, my number is a variable, it's not constant. At this point, it has the value 5. At this point, it can have another variable, and then I can display it again. So is storing is storing. When I run, you're gonna see that this variable stored two different values. At some point, it was storing 5, and then at another point, it was storing 10. So this is why it's called variable. Now, when it comes to variable naming, you're not allowed to have spaces per language rules or syntax. They have to be one word. And we use this style called camel case. Camel case means the first letter of each word is capital letter, because if I say my gross pay number, for example, and then I look at this, it's kind of confusing to read. I have to spend a couple seconds analyzing and reinterpreting what this means. However, if I use camel case, my gross pay number, this will help kinda read this name. Okay, my gross pay number. Another style is using dashes, for example. Sorry, maybe dash is not allowed here. Underscore is allowed here. Another style is to use underscores between the word. I personally love camel case, which is like this. So this tells you the difference between variable and literal. The next thing is identifiers. Identifiers are basically, so variables are one of the identifiers. Identifiers are choosing variable names to indicate what the variable is used for. So if this variable is used to store my number, I should call it my number. If this variable is used to store gross pay value, I should give it a proper name. I should call it gross pay. I shouldn't say my name and then store gross pay in it. So I should identify what this variable does using its name. An identifier, as a definition from the book, is a programmer-defined name that represents some element of a program. So variable names are examples of identifiers. You may choose your own variable name in C++ as long as you don't use any C++ keyword. For example, this is a keyword. This is a keyword. This is a keyword. So I cannot say I need an integer called return. This is not allowed because this is a keyword. I'm not allowed to use any keyword from the C++ language. On page 42, table 2-4, it shows you all the C++ keywords. You're going to see you have a long list: true, throw, try, void, size of, short, integer, long, delete, do. All those keywords you are not allowed to use as variable names. Next is to go over the integer data type. So there are many data types in the C++ language, and variables are classified according to their data type. The data type determines what am I about to store in this memory. Each data type has its own size in memory. Integers, for example, can hold whole numbers like this, or like this, or like this, any whole number. So I'm not allowed to store decimal. In this case, the decimal will be ignored. So my number, when I display it, it will only display the whole number part, the portion where it doesn't have a decimal. Notice, it only displays the whole number. This is what integer stores. This is what the classification of this data type. In general, you need to know a few data types that are primitive. Primitive means this means provided by the language, and I'm gonna go ahead and list them here. You need to know short. You need to know ints. You need to know um, long. You need to know before we go to floating point, these are for whole numbers. So these will store whole numbers. The size in memory is 2 bytes. Integers are 4 bytes, and you need to memorize these for this class. And longs are 8 bytes. The range of values for short is -32,768. You don't have to memorize this. So from negative to positive. From negative to positive, this is the range for short. You can think about it as you have 16 bits. So one, because every byte is 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you have 16 bits where you can switch on or off, something like this. Each digit represents a 2's complement. So this will represent 2 power 1, 2 power 2, 2 power 3, 2 power 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6. 2 power from 2 power 1 to 2 power 16, either on or off. If I switch all these to on, then I'm gonna get this number. You can think of it this way. So integer shorts are 2 bytes. This is the range for it. shorts are 2 bytes, integers are 4 bytes. So the range for 4 bytes, imagine you have 8 times 4 bits, and the range for integers is a little longer or bigger range because it's 4 bytes. It's kind of double and even more double because of the 2's complement. And it is 483,648. Again, you don't need to memorize this. So from negative all the way to positive. When it comes to long, it's also a bigger number. So it goes from 223, 372, 036, 854, 775, 808, from negative to positive 9, 223 would be similar all the way to the end 775, and then the end is -1. So 808 negative to 807 negative. The idea here is if you know that you are using a number or you are about to store a number within this range, for example, IDs, let's say number of students. In my class, I'm not going to have more than 767,000 students. I'm going to have maybe 20, maximum 100, right? So if I know that the range is less than this, I better use short as a storage variable because the lesser the memory, the better, the faster for my program to execute. Instead of using an overwhelming 8 bytes for storing only 30 numbers, I should use short. These three, short and long, are unsigned. Signed. So red. These are signed. And when I say signed, signed. Signed means they have a sign next to it, either negative or positive. With this same three types, I can use unsigned short, and it is called unsigned short. I can use unsigned int. I can use unsigned long. This means there is no sign next to it, so the range is always from 0 and up. There is no negative, there is no sign. So the range for an unsigned short is 0 to double that number. The range for unsigned integers is 0 to 494, 2946, or 967, 295, and the range for this bad boy is double what we witnessed above. So 446, 744, 073, 709, 551, and last one is 617. So again, you don't need to memorize this, but you need to know the idea. Imagine the range is -10 to 10 for signed short. So the range is 0. I can store from -10 all the 10 in signed shorts, which is also short. So if I don't specify, then it is signed. When it comes to unsigned, I have to specify unsigned. Then the range becomes, since this is 20, so you want to imagine it as 0 to 20. So it's the same bytes, same number of bits, but it's either with 0 or either with negative or without negative. So the capacity is the same, but either half of it below 0 and half of it above 0. In unsigned, all of it is above 0. This is for whole numbers. Notice there is no decimal. The table on page 44, table 2-6, provides you the difference between short integer and long, and unsigned short, unsigned integer, and unsigned long, and their sizes and their ranges. You need to memorize their sizes, but not their ranges. Then another type you need to know is hexadecimal values. Hexadecimal values. Why do you need hexadecimal values? Hexadecimal values are needed because of the fact that memory addresses are in hexadecimal. Hexadecimal values are base 16. So in order to give you an idea, we as a human beings, we have base 10, which is any number that is of the set 0 to 9. As a human being, we communicate with numbers. Whatever number you need to create, it's going to always contain one of these sets. For example, the year we are on. The year we are on is 2 from that set, 0 from that set, 2 from that set, 3 from that set. All the numbers that I possibly can create would be from this set because we communicate in base 10, 0 to 9. And anytime I am incrementing my number, when I reach the end of the sequence, means 9, I repeat. So I start over with 0, meaning if I am counting or incrementing 5, 6, 7, 8, 9, and I reach the end, then I'm going to repeat the sequence and increment the most significant value. So I'm going to repeat 11, 2, 3. Once I reach the 19, I'm going to repeat the sequence and increment most significant one. Once I reach 99, I'm going to, this would look 099. I'm going to increment and start over. Then I'm going to reach, for example, 09. I increment and start over. So base 10 will always go to the end of the list or set and then repeat. With that being said, hexadecimal values are base 16. So base 16 are from 0 to F, meaning I have 0 to 9 and then A, B, C, D, E, F. And similar, when I am incrementing, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F. When I reach the end, I'm going to start over. So I'm going to start over with 0 and increment. So 0 to F and then 10, 11, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. All those are incremented. 17, 18, 19, 1A, 1B, 1C, 1D, 1E, 1F. Now that I reached the end of the sequence, I'm going to repeat and increment. I will at some point reach FF, which is the end of the sequence for this digit and the end of the sequence for this digit. So I'm gonna increment and start over. So memory addresses in computers are built of hexadecimal values. So you want to think of it as memory block that starts as address 0 all the way to F, and then 10, 11, all the way to FF, for example, then 100. So all these slots are in hexadecimal value. If I tell my compiler, here I have my variable or my integer, and I need to display the memory address of my integer, it's gonna display hexadecimal, not a whole number, not a decimal, not a string. It's gonna display a hexadecimal value. It's gonna display something like this: 0, 0, 0, 0, 0, 1, A, C, 9, F, B, 3, 9, B. Something like this. This is the value of the memory address while my integer is stored. The next data type you need to know, so now you know short, you know integer, you know long. The next one you need to know is char variables or char data types. Char data types are a single character and they are within single quotations. For example, A. A as a character would be stored in a char data type. For example, I go here and I say I need a char, my char. I need my char to be equal to A. It's a single character. See out my char and L and I execute. Here it is A. It's a single character. One character. I cannot have two characters. It's gonna say if I tell it I need two characters, then it has to be double quotations. So now it's gonna say, hey, you can't do this. You're trying to give me a string to put in a char. It's interesting that it didn't underline this for me. What would this display? B. Okay, so it ignored everything. How about A, B, C, D, E? Oh, now it didn't like it. Interesting. Too many characters in character constant. So if I put 3, it likes it. Interesting. So ABC will display C. ABCD will display D. So up until 4, it will keep displaying. Okay. So single character. Characters in memory are 1 byte. Just like you saw, shorts are 2. Let's go to, yep. So size is 1 byte. 1 byte means 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. It can either be 0 or 1, something like this, for example. And it's also 2's complement. Now, this will be evaluated to a whole number, if you remember. There is a range. If all are zeros, it's 0. And if all are 1s, then it is 255. 0 to 255 is 256, which is 2 power 8. So if all are 1s, then it's 256. It's 2 power 8, sorry, it's 2 power 8 plus 7 plus 6. So it's all of them. Or you can say it's 2 power 9 minus this. Forget about this, just so I don't confuse you. But you have 256 values that can represent a character. So this will evaluate to a whole number between 0 and 255. Every value represents a character. And we go by the ASCII code. So there is a table called ASCII table. It's in the book, at the end of the book. Or you can go to Google and say ASCII table. So this will show you, visit. This will show you from 0 to 127. There should be more. Negative. Okay, so there is unsigned 127, and then there is signed 127. Okay, so anyway, notice, for example, the character 0 is the value 48. The character A capital letter is 65. The character A small letter is 97. This is the decimal value, which is what you see in the bits. Then this is the hexadecimal. Notice from 0 to F, and then 10, 11, all the way to something like this. And then the character, the actual character. So if I tell my compiler I need to display the character 53, it will display the character 5. So this is for the character data type. Then you need to know the difference between character and a string. In brief, a character is a single character. A string is a group of characters. So suppose you have literals A and double quotation A. This is a string A, and this is a character A. This is a string of one, consists of one character, and this is just a character. It's not a string. It's just the single character A. However, this is a string, but only have one character. Let's say my first name is a string, but it's only one character called A. My name is A. This string has under the hood the character A along with null termination. So first, notice the double quotation, which are not stored in the string. So the double quotations are not part of the storage. Mean something like this here. The string is pause null. Double quotations are not in memory. So if I go to the drawing and I draw the string pause, in memory, this looks something like this. It starts with the letter P, then the letter A, single quotation, notice. It's single quotation. The letter U, the letter S, the letter E, and finally null terminator, which is 0. This null terminator is hidden in the computer, in the program, sorry, and on the screen, but this will determine the end of the data, the end of the string. So when I tell my program to display a string pause that is stored in some variable, it will know that it needs to keep displaying up until it encounters the null terminator. This is not 10, it is the backslash 0. So it's one character backslash 0, similar to backslash n that you saw, backslash t, it's backslash 0. And backslash 0 is the value 0 as well. So if I tell my computer or my program to display, there is no display for null, but if I tell my program, hey, I need you to have a storage for a string that have the letter P, A, U, S, E, and then I give it value 0, not the character 0, the value 0, it will know that it's the null character. Then so just so you know, this here is called C string. So C string is from the language C. The one we are learning is C++. The C string, so the string from the language C, is an array of characters or a group of characters, just like you saw above. And they are null terminated. Then you have the C++ string, which is string. So you either have C string or string. String is not null terminated. It is a class provided by C++ that can store group of characters. It's not an array, it's a class, it's an object that stores multiple or group of characters. And this class provides you with functionality also without you doing anything. So if I create data type string and I give it some group, I can operate on that data with a bunch of functions. You have, for example, length. Length will tell you how many characters are there. You have a lot of functions, str, for example, this will convert it to a C string. The book actually gives you a lot of info about strings later, but let's give an example. So let's say I need string L or my string. So this alone will confuse my program because I have to tell it that I need to use the string library, the library provided by the language. String, my string, I'm gonna say my string equals, it has to be double quotation. If I give it a single quotation, it will not like it. It's gonna say, hey, oh, it did. Maybe they updated because they keep updating the language and Visual Studio. We are now on 2022 Visual Studio. So anyway, I can give it a string of one character. Hide. Let's hide this here. Oops, sorry. Yeah. Hide. Okay, sorry, back. And I can give it a group of characters, and this group of characters will be referenced in one storage unit. So I can display my string and L. Here it is, group of characters. The next data type you need to know is the floating point. We forgot about the floating point. You have floating point data type. Floating point are data types that store decimal in them. So it's a whole number including decimal portion part. Or you can say it's decimal numbers. That floating point store decimal numbers, meaning I can store 10.5 and it will reserve the .5. I can store 21.7. I can store 1001.0006, for example. So floating points will reserve this portion, this part. You have a decimal notation, which is like this. For example, the number 247.91. This is the decimal notation. For this same number, you have a scientific notation. Scientific notation start always with one number, and then in this case, 4791 times 10 power 2. This is called scientific notation. Then you have exponential notation. Exponential notation is, in this case, 4791 E2. This is E notation, exponential notation. All these three are just a display thing. Under the hood, all these three are stored as 24791, which is the decimal number. The decimal number can be represented in different formats. You, in this case, under this same umbrella, you have either what's called float, so a data type called float, data type called double, and a data type called long double. In this case, this size is 4 bytes. So similar to what you saw with integers, short and long, all of them store decimal parts, but they are bigger. So they are different in size. Double is 8 bytes, and long double is 8 bytes. And similar to what you saw in signed versus unsigned, you have signed float and unsigned float, signed double and unsigned double, long double and unsigned double as well. The only difference is the range of values. We also went over assigning a float number to an integer data type, and that will cost me the decimal part. So if I have a variable called my integer and I say my integer equals 7.5, I'm gonna lose this part because integer values only store the whole number. It doesn't reserve the decimal part. And the last part that the book needs you to know is the Boolean data type. A Boolean data type stores basically 0 or 1 only. So it stores false or true. I can say I need a Boolean, my bool, semicolon, and then I can say my bool equals 0, means my bool is false. Or I can say my bool equals false, the keyword false. I would use Boolean and we would use Boolean in interactions with conditions. So there has to be, or there would be some condition, and then I'm gonna check if that condition exists or not, if it's true or false. So that value, whether it's true or false, would be stored in a Boolean. For example, a variable called, or a feature called is connected. Is connected would be a Boolean variable, and it would store either false or true. So it's either true, yes, it's connected, or false, is connected equals to false. That means it's not connected. Again, working with proper variable names give you big advantage. Is connected for Booleans, it starts with is. It's good to start with is because it's a Boolean. It will reflect and identify what this variable means. If I can use connected and it will make sense, but it will make more sense if I use is connected. The last part in this topic is to know the way of knowing what's the size of your variable. And it is the function called size of. There is a function called size of. Size of takes any variable and it will return number in bytes. So size in bytes. For example, Boolean, by the way, are 1 byte. Yes, they store only 1 bit, 0 or 1, but the smallest unit in C++ is a byte. So I can say, for example, my integer or int, my integer equals 10. This is another way of declaring and assigning value right away. I can say size of my integer. And this will display the size in bytes of my integer. In this case, it's an integer, so it will display 4, because integers are 4 bytes. Then the next topic is arithmetic operators. Arithmetic operators are what you know in math. Arithmetic operators are, so let's go and type arithmetic operators. Again, it's math. So you have the plus, you have the subtract, so addition, subtraction, multiplication, not an X, it's the asterisk, it's the star character. So it's shift 8 character. You have the division and you have the modulo operator. All these 5 operators are arithmetic operators. So this is used for adding one variable. So adding a variable, not the value 1, adding a variable to another variable. So the value of a variable to another value in another variable. This is basically subtracting. This is multiplying. This is dividing. And this is remainder. So finding the remainder of a number within another number. For example, I'm not going to explain the above because they are clear. But the modulo operator basically saying something like this, 9 modulo 2. What is the result of this? Meaning, if I divide 9 over 2, what is the remainder? Or in other words, if I subtract all the 2's from the 9, what would I get left over or left off? If you take off all the 2's from the 9, what would you keep? You would keep 1, because remove 2 becomes 7, remove another 2 becomes 5, another 2 becomes 3, another 2 becomes 3, then you are left with 1. You cannot take 2 from the 1. Another example is, for example, let's do 5. 13 modulo 5 is 3. If I take all the 5 from the 13, then I'm left off with a 3. And it's very useful operator, and it's very fast. For example, one simple use of this operator is knowing if a number is odd or even. I can say if, for example, my integer modulo 2 equals 1. This statement, and we're going to go over this later, but this statement is basically checking if my integer is odd or even. Why? I'm telling it, if I take all the 2's from my integer and I am left with the value 1, that for sure means it was odd. So it would look something like 131. If I take all the 2's from 131, I'm going to be left off with 1. On the other hand, if my integer remainder 2 is not 1, so you're gonna have an if else. So here it's odd and here it's even. If a number remainder 2 is not 1, that means it was an even number. It would be something like 12. If you take all the 2's from the 12, will you be left off with 1? No, you will be left off with 0. So the fact that you are left with 0, that makes this statement false. So this part will not execute, but the else part will execute. And we're gonna go over if statement later, but I tried to explain one basic usage of remainder operator. With that being said, you need to know integer division. The book needs you to know about integer divisions. So integer divisions, you need to know integer division, which is very important. First thing you need to know is you can't divide by 0. Divide by 0. You will crash. It's crash. It's not simple. It will crash your program. Another thing you need to know is you need to convert. Sometimes you need to convert, otherwise you lose the decimal part. So basically what I'm trying to say, if I say I need a double data type called my double, and then I say my double equals 5/2. 5/2 is 2.5, but in this case, my double will store only 2, and it will lose the decimal. Why? Because when you divide integer with an integer, the result is an integer in C++. What you need to do is you need to convert one of them to be decimal data type in order to reserve the decimal part. So in order to get the 2.5, I need to tell my program I need to divide 5.0 over 2. You need to pay attention to this because it's very sensitive. A lot of times it will look right, but it's not right. You're gonna be having bugs and you're gonna look on your code to try to find what's wrong with your code, and it will make sense. You're gonna look at it and you say, okay, 5 over 2 is 2.5, then my double value is 2.5, and then you're gonna continue with the code trying to find what's the problem. So it will look right, but it will not be right. You need to convert one of them to be decimal in order to reserve the decimal part. Next thing you need to know is comments. Comments. We went over single line comments, but you have two types. You have single line, which we already went over, which is using the 2 forward slashes, and then you have block. So it's a block of lines, and they go by forward slash asterisk and then asterisk, also forward slash. So anything in between would be commented out, even if they are on multiple lines. For example, let's say I want to comment this part. I'm going to say this function does X and Y. This is a single line comment, so it only comments this line. It doesn't comment the rest of it. This is now an error. In order to comment this part too, I need to comment it again, because this is a single comment, this is a single comment. Or I can use a block way, which is forward asterisk and then end it with asterisk forward. So now this makes this block and anything in between as comment. Notice anything in between is a comment, so it's a block. And Visual Studio provides me with collapse and expand feature for this block of comment. And this is it for the chapter. The last part was about programming style, and they speak in brief about programming style. Programming style is what I mentioned. The style you use in your code. For example, my integer camel case. I personally, and you're gonna see it in examples later when it is our concern and it is our interest. Here, my interest is not providing you what each style means. Here, what my interest in this chapter was to explain different parts of the program. I personally, for all the local variables, I use L at the beginning. This will indicate anywhere else I use the function that this variable was created locally. It didn't come from outside the function. Anything that is outside, I would use G for global. So global my integer, for example. Anything that comes from outside the function, so int A my integer. This stands for an argument. It's an argument integer. So anytime I use this variable, it will tell me, it will indicate to me, oh, it starts with A, so this was not declared locally. This is not a global variable. This variable was sent to me, was sent to this function. So programming style, there are a lot of styles. There is no like one style that you need to follow. There are a lot of different style. Every company might have its own style. So as long as there is a style, as long as between the same team you agree on one style, it's enough. If every developer has his own style and then you guys work on the same file, for example, then you're gonna have a function that has pieces of code. Every piece is in one style and it will become confusing really quick. So it doesn't matter. At the end of the day, it doesn't matter which style you use as long as you use a style. So that was the idea I was trying to communicate, and this is it for chapter 2. Please let me know if you have any questions.